What if your factory can predict failures before they happen, capture decades of human expertise, and make better decisions than ever before without replacing the people who run it? Today's guest sits at the intersection of innovation and industry. Welcome, or hopefully welcome back to Reliability Matters. Bryan DeBois, Director of Industrial AI at RoviSys, is helping reshape what manufacturing looks like in the age of intelligent machines. From predictive analytics that catch problems before they happen to data-driven systems that optimize production in real time, Bryan's work is transforming how factories think, learn, and produce. But this isn't about replacing people. It's about amplifying human expertise and capturing decades of industrial knowledge before it disappears. In this episode, we'll explore how smart factories are changing the game, what it really takes to begin a digital transformation, and why trust and transparency are just as critical as algorithms and code. What stands out most is Bryan's ability to make advanced technology practical. He's not talking about theory. He's helping real manufacturers integrate AI in ways that improve safety, efficiency, and sustainability. I'll speak with Bryan about how artificial intelligence is redefining manufacturing, the challenges of digital transformation, and the future of smart factories when I return in just a moment. Stick around, this is going to be good.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, Bryan. Good to see you. Thanks for being my guest today. I'm looking forward to this conversation.
Yeah. Hi, Mike. Yeah, glad to be here.
Well, I'm glad you're here as well. So, Bryan, before we get into smart factories, can you tell us a little more about RoviSys and your role in helping manufacturers modernize their operations?
Yeah, for sure. So RoviSys has been around since 1989, and we really started on the plant floor. So we were doing control systems integration, those types of projects where we're doing ladder logic and programming PLCs, and this is really, for your listeners, this is the hardcore stuff that actually makes plants, operate and run. And then over the years, we've added more and more capabilities, particularly in the in the ISA 95 stack, what would be called level 3 in the plant floor. So level 3 is where all of your information solutions happen. That's where we're taking the large volumes of data that the plant floor can create, and we're doing something interesting with it. And early in my career, we were doing things like building manufacturing execution systems, and we were leveraging historians, which are time series databases, to do everything from visualization to OEE. And then in 2019, we hit our 30-year anniversary at RoviSys, and we really said, what's next? And we started 3 centers of excellence in 2019.
Sorry, Bryan,
one
I got to interrupt you just for a second. 30 years at RoviSys.
Well, it was 30 years. No, I have not
been
at
but
RoviSys
has been around for 30 years. That's what you're saying, right?
Oh, yeah. Well, in 2019, we were 30 years old. Yeah.
That's amazing.
Now, 36, 37?
That's amazing.
Yeah.
I assume that a company in this space that is, integrating AI and other things would have been a startup, would have started maybe 8 days ago. It's super impressive that a 36-year-old company is, charging into this space. I don't know why. I mean, obviously it's possible, and why not? But it's just surprising to me.
Yeah, I think it's one of the things that RoviSys does well is that we don't, we don't sit back and just relax. Like, we're always looking for what's next, what's new, where should we be pushing ourselves? Not everything works out, but this one has. And so in 2019, we said we need to be starting an AI division. And this was, you remember 2019. So we're still at that point. ChatGPT, I think, was November of 2022. So we're still 3 years away from the announcement of ChatGPT when suddenly everyone was talking about AI. So I was going into meetings with customers and saying, hey, I'm the director of industrial AI. And they're like, what's AI? Like, what does that even mean? And so we've been doing it for a long time now. We've got real models running in real plants, adding value to our customers. So we feel like we actually have been at it long enough now that we know where the pitfalls are. We've done it enough, and we know how to get value out of these AI projects. And I think that's going to be something we're going to talk about today. Is that, as you mentioned in the intro, right? Like, this is about finding ways to leverage industrial AI to have practical impact on the plant, right? So what we found when we talked to customers is they had the ability to build models. In some cases, they had small data science teams, so they were able to build models. The problem was that they couldn't actually operationalize those models on the plant floor. And it turns out that that's the most important part, right? Because until that last mile, until you're actually, someone on the plant floor is using that AI model to make better decisions, until that happens, you haven't seen a lick of ROI. Everything up to that point has been a big science experiment. And so we really felt like, with our expertise on the plant floor, implementing technology on the plant floor, we were really well positioned to bring that specific capability, operationalizing AI, to our customers. So that's how we started. Yeah.
Wow, fascinating. So the term, and I'll put it in air quotes, smart factory. There's certain terms that I always put in air quotes. Back in the 70s, everything was turbo, right? There was a turbo button on my PC that would basically, I think it ran at 16 megahertz. They built it for 32. They shipped it out. It would run at 16, but if you hit the turbo button, it would run at 32, which it was designed to do anyway. There's just a lot of industry buzzwords that are simply buzzwords, and then there's the real root meaning behind those words. So let's start with smart factory. It's a popular term. How do you personally define smart factory, and what separates a truly smart factory from one that's just automated and kind of leaning toward the buzzword?
Yeah, and I think you hit the nail on the head there. Some of this stuff is just so, there's so much hype around it, and some of these terms are really more marketing terms than anything. And I remember early in my career, so this would have been in the early 2000s. I've been at RoviSys for 26 years now. When I started in my career in the early 2000s, we were, that's really when I felt like we were talking about smart factory, right? And we first started in the digital factory. And then Industry 4.0 became a big term, and that kind of came out of Europe. And the idea behind that is that we're in the fourth industrial revolution. Now people are saying we're in the fifth. I was like, well, what happened with the fourth?
Yeah, four didn't last long.
No, it sure didn't. And then digital transformation became kind of the term. I think what it is, like getting away from some of the marketing hype, I think what it ultimately comes down to is those customers that are focused on continuous improvement. And what that means today is it does mean leveraging digitization to have a transformative effect on the day-to-day operations of the plant. That's how I define digital transformation, which is the term I prefer. But really what that means is a focus on continuous improvement. And so those plants and those customers of mine that have been making that investment and have been focused on continuous improvement this entire time, they're finding that this is just a natural progression for them to now start to look at AI and adopting these types of more advanced technologies. Where some of my clients, I can already tell they're going to struggle, are those customers that have not had a culture of continuous improvement. And so, they've got folks who I'm meeting with on the plant floor, and they're like, look, I love this AI stuff. I'd love to do that, but I've got a piece of equipment here that is 30 years old. It's held together by duct tape, and I can't commit that. I was in a meeting a couple months ago with a customer, and the guy whose job it is to maintain this piece of equipment said, I will not sign my name off that this machine is going to be running in the next year. They're buying parts off of eBay and stuff like that. So this is where the rubber meets the road, and those companies that have maybe invested that money elsewhere, and instead of putting it back into the plant, I think are going to struggle with the smart manufacturing and this digital transformation kind of thing. But those customers that have done that and they've been making those investments, what we're finding is that we can now build on the investments that they made. So when I started in the early 2000s, we were still beating the drum on data historians, process historians. You need to be capturing every piece of data coming from the plant floor, that there's going to be a ton of value in that data. And I remember in the early 2000s, I had a customer who said to me, well, why would we capture that data? We just throw that data out. Right. And that sounds quaint now, But in the early 2000s, that was the mindset, right? Why would we ever pay for a data historian that's going to store all this data, right? Now, you fast forward 20 years, it's like, oh, this was why. AI was the reason why. We were telling you. We couldn't have told you maybe at the time exactly why, but now we know this was the reason why. Because
someday something's going to consume all this data.
Exactly. Right. And I mean, even in the early 2000s, I think people were still saying data is the new oil. I mean, we knew that there was value in this data. And so those customers, I'm walking into those customers right now and I'm saying, okay, you got that data. Let's go ahead and start building some AI models off of that data. So I think all of that is the smart manufacturing. I think that automation and AI is going to be such a key aspect of moving forward. And we'll probably talk some more about this today too. But like this concept of reshoring and bringing U.S. manufacturing back, we're going to need to rely on robust automation and AI to be able to actually make that a reality.
Yeah, you mentioned something a little bit ago that, some companies are, basically running on duct tape and, hope or something. And I've got a plan. We have just introduced smart duct tape. So to go along with the smart factory.
There you go.
There we go. Speaking of smart factory, just a real quick distraction here. I was in Austin, Texas last week, and I was quite privileged to tour the Tesla Gigafactory in Austin. 11 million square feet. It's phenomenal. The building is a mile long, a half a mile wide. It's 4 stories tall. And they build the Cybertrucks and the Model Y and batteries there at the moment. And the Model Y, according to the tour guide, who must know, 90% of the Model Y is produced autonomously. Robots and high levels of automation, and I've never seen so many robots in my life and automated processes. And I would imagine that if any company embraces the legitimate version of smart factory, that's got to be one of them. Elon Musk's sci-fi mind and visionary technological skills, and money built that factory, just 3 years ago, 4 years ago now, 2022. It's the first time I've seen what I'm not qualified to say if it's the RoviSys version of a smart factory and embedding AI and all that, but I would assume it has to be, because you can't build that with smart duct tape and hope. You got to build that with leading edge technology, maybe even technology us mere mortals can't afford yet. But it was the first time I've seen the benefit of a real smart factory. I feel like I just got a 11 million square foot tour of the future, right? And that technology will, I won't say commoditized, but it will become a little bit more commoditized and more democratized, so that small factories can adopt into that infrastructure as well. That was fascinating to me. Over your career, how have you seen manufacturing evolve from basic automation to data-driven, AI-enabled operations? I mean, you've been sitting on the front row of history here.
Yeah, and I feel privileged to have seen everything I've seen. I think when I started my career, it really was about just installing PLCs and creating automation, early automation and P&ID loops and those types of things. But as and it was very hardware centric. I mean, when I started my career, RoviSys was still soldering boards in some cases. Now, we haven't soldered a board in a long, long time, but that was the case where you couldn't always go out and buy an off-the-shelf, component to be able to do some of the things that our customers wanted to do. What I've seen the arc of my career is two things in particular that have led to this AI future. One is we talked about this data and collecting data. And when I started my career, a lot of the equipment you were lucky if you could get maybe 10 data points off of it. Now everything on the plant floor is smart. Now everything can give you 100 data points about how it's operating, right? So that's been one of the things. But the other thing has been the influx of software. if you guys aren't familiar, if your listeners aren't familiar, there's a new push now. I think it's called universal automation. But basically, the idea is that leveraging software all the way down to the controllers, the PLCs, and being able to push software programs. And so everything on the plant floor is starting to become more of an IT centric, more of a software centric type of approach. And I think there's a lot of benefits to that. So those two things, though, in particular, I think have really unlocked our ability to be able to leverage AI on the plant floor. I think, though, another thing for folks to keep in mind is that you've got the Teslas out there, and I'll throw another one on there. If you've ever been in an Amazon fulfillment center, it looks like the future. It's unbelievable how advanced the stuff is that Amazon's doing. To your point, that stuff, they can afford it. They're very cash flush, those companies, and they've made these investments. To your point, it will start to become a commodity, and we're already starting to see those things start to trickle down into the more mid-sized type of companies. But I think it's important for customers to understand, too, that this doesn't have to be like sci-fi. We don't have to look at AI on the plant floor as if it's something that is unachievable for a mid-sized business, maybe even a small business with a lot of forward-thinking folks there. There are some very specific things which we can talk about today that would be first, low-hanging fruit, the first types of projects that they could bite off and really start to apply these AI improvements to their everyday operations.
You talked about the sheer quantity of data points that, basically cheap memory has allowed us to store.
Yeah.
In addition to the volume of data points, let's talk about the quality of those data points. What role does data quality play in achieving meaningful AI insights on the factory floor?
It's important, and it's actually where we start. So when we start one of these projects, we do what's called an exploratory data analysis, or EDA. That's where every one of our projects starts. And the reason why is because that data quality, as you mentioned, is such a key part of everything else is downstream of that data quality. And so the types of things we're looking for is the data complete? Right? Are there gaps in the data? Is there dirty data? Can we determine that maybe there was a bad sensor, or those types of things? And what's interesting is that those are the types of things that we have to deal with in the OT space that our friends in the IT space typically don't have to deal with that, right? So when you look at the types of, when they're doing AI in the IT space, they typically have large volumes of very clean, very correlated data. And typically they're measuring the number of rows that they have in the millions, right? So the typical approach, data science approach in that space, is that if you get a row that is missing a column or has bad data, you just throw it out. Well, in the OT space, you can't really do that in a lot of cases. Sometimes that one row might be, represent, a product that you don't make that often, so you can't really throw that out. We typically have to deal with hundreds of thousands of rows of data, not millions. And so and we're also, OT data is known for being heavily siloed. It's very dirty. And I talked about the gaps and the dirty data. So these are the types of things that we're doing. So we are first doing this exploratory data analysis, and we've got some algorithms that we run to make sure that data is actually going to be able to work to provide the AI models that customer is trying to do. If we find that there's gaps in the data, if we find, which happens sometimes, that, okay, this data set is good, but it's missing this one key data point that you didn't capture. So then we propose a small project to the customer to go in and add those couple data points. Maybe we have to add new instrumentation or whatever, but add those couple data points to the historian so that now we can complete that data set, and now we can actually be able to attack those ML models that they want to do. But that data quality it's always the very first step.
There's always a fly in the ointment somewhere, right? So what if, say you have a potential client who comes up to you and says, RoviSys, I love what you're doing. I want to be like a gigafactory or an Amazon fulfillment center. Help me get there. But they have equipment that they bought on eBay that came from the, Henry Ford's Model T factory, right? And, because we're dealing with, in this industry, we're dealing with equipment that has gone through several evolutions, In fact, sometimes by the time it's delivered, it's already obsolete. At the pace of evolution in our industry. So, to that point, many manufacturers have decades-old systems. What's the biggest challenge in integrating legacy equipment, which could be 6 months old, but legacy equipment into a digital ecosystem?
I think that, and I think it's really important because we have to meet customers where they're at. When RoviSys comes into a factory, we assume that everything has to stay. We don't assume that we're going to be able to rip out any of this equipment, right? I'll give you a quick story. So this is one of my favorites as when you talk about real legacy equipment. We've got a customer in the Cleveland area, and they are running an electrical generator. And that generator, the drawings for it have Thomas Edison's signature on those drawings. It is a 100-plus-year-old electrical generator. They actually have to step it up because it runs, and I'm not an electrical engineer, but it runs at a different, frequency or whatever than modern ones do. But it's been running, and it's one of those things where nobody wants to touch it,
right?
Because it works. And but they also have they have the original, the way it was originally run is there's literally wooden levers. And then, in the next room over, you have the big light panel things that you saw from like the 60s. And then in the next room over, you have modern computers. And that's what controls it, right, is the modern computers. But nobody wants to touch any of the intermediate steps because nobody wants to screw it up. So if that company can pull data from that, and if we can instrument that piece of equipment, we can instrument anything, right?
That's a great example.
So it's not so much a question of how do we get the data. We got 100 different ways to get the data off it. And I mean, I had a paint company that so they make pigment, and some of their mixers are so old, there's just not even any way to instrument it. But we can at least there's things that we can actually add to the power cables that we can detect current and things like that. So we could at least get an idea of on off and maybe even how fast it's running and those types of RPMs, those types of things. We can calculate those types of things. So there's plenty of ways that we can get the data. Taking that first step and getting that data. So a good example. So we went into a company, and they're a kind of a mid-sized company, and they make a very niche product, but they're very, very good at what they do. And they wanted to get to robots, and they want to get to this future state, which I'm all for it. I love it. Let's do it, right? But they are collecting no data. And I'm like, okay, guys, well, I can't program a robot to do anything that I don't have data for. I can't build an AI model to do anything that I don't have data for, right? So until you have collected that data, we're dead in the water. We can't do anything. So but it's such a utilitarian kind of step. It's not what they want to hear. They want to hear about how you've got these 5 ideas for, humanoid robots. It's like, no, it's more block and tackle than that. We have got to collect data off of this existing equipment. Now we could start to even, approach a project where we start to add robotics in or something like that. But until we can model it with data, then there's no chance of us being able to automate any of it. So.
In your view, what's the right balance between human expertise and machine intelligence in today's smart factory environment? I hear this term all the time, lights out factory. And I think that is definitely a marketing term. The folks on Madison Avenue did a good job with that one. I don't think it is a literal, application of this. I just can't imagine. Although maybe that's my short-sightedness. Maybe I'm showing my ignorance, but I just can't imagine a true lights out factory. Even the Gigafactory had employees in it, right? I saw a lot of them. I think they have 8,000 or 12,000 employees that work there. But at any rate, where's the balance there?
Yeah. Well, let me address that real quick. So I 100% agree with that. With this lights out factory is a hype. It's a marketing term, and you hit the nail on the head. The 2 most advanced factories I've seen is the Gigafactory and an Amazon fulfillment center, and there's plenty of people there.
Yeah, no shortage.
No, there's no shortage of people. We're not worried about that.
In fact, there's so many people there. They have a bus system that rivals a small city to move people around the parking lot. You actually take a scheduled bus service. You stand at a covered bus stop in their parking lot.
Right. Yeah. So humans, there's still lots for us to do. There's no worries about us, robots or AI putting us out of work. That's science fiction. But what they are running short on is expertise. And so what we're finding is that as the baby boomers are retiring, they're taking with them all of that expertise on how to run this equipment, how to maintain this equipment. And there does not appear to be a workforce, at least in the US, there doesn't appear to be a workforce that is coming in to replace those baby boomers. What I'm hearing from my clients is that they have high turnover, that many people are just approaching these types of factory jobs as an entry-level job where they'll stay for six months if you're lucky, and then they quit and they're off to the next entry-level job. So nobody seems to want to stick around long enough to make that investment, to spend the next decade of their career and really build a career at one of these sites and really learn how the equipment works, learn how the process works. They're not interested in that. So expertise is what we're losing, and we're losing it really fast. So to give you a quick number, so LNS Research did a study, and in 2019, the average tenure in the U.S. workforce, the average tenure of a manufacturing employee was 20 years in 2019. 4 years later, in 2023, it dropped to 3 years.
Wow.
So we lost 17 years of expertise in a 4-year period. And COVID obviously played a lot into that. But these baby boomers, they knew how to run this stuff, and they're gone or they're leaving soon. I went to a vinyl extrusion operator up in Canada, and I was sitting down with the plant manager, and the very first thing he said, I've got 2 guys who know how to run this vinyl extrusion line better than anyone in the world, and both of them are less than 5 years from retirement. And he said, I've got no bench. I've got 1 year or less guys. I've got high turnover. It is the world that we're living in now. And so in order to be able to close that gap, expertise is going to be the thing that is going to be in the most high demand. And so how do we capture that expertise, and how do we put it into AI to be able to advise those people on the plant floor? So there was a study I saw in January of last year, and they asked manufacturers, where do you want to leverage autonomy and AI on the plant floor? The number one result was they wanted to use it to help advise younger operators, novice operators. So the goal has never been to put people out of work or to try to replace them. They don't even those manufacturing customers, they don't even want to do that. All they want is they want smart systems that can look over the shoulder of a novice operator and can help them operate the plant as well as it used to 5 years ago when they had all that expertise in the plant. Many of my customers are just trying to get back to, they have seen a drop in throughput, drop in quality. They're seeing increased costs on the plant floor. In many ways, they're just trying to get back to where they were 5-6 years ago, right, in terms of operating the plant. And they're getting kind of desperate now. One of the things that, and I don't want to see this happen, but one of the things that I'm very concerned about is that we're going to see more quality issues. We're going to see things in the food and beverage industry. You'll see outbreaks. And I think we're already kind of starting to see this, major recalls as those plants are putting out low quality product because nobody involved knows how to make good product anymore. And so sure. I'm trying to ring the bell here. Like this is going to be a real issue. And so look, AI is part of the solution. It's not the whole story, but AI needs to be a part of any strategy here to try to get back to making good product on a day-to-day basis.
Yeah, whenever I hear people say, "Oh, AI is taking all our jobs," everyone's going to be out of work. I just widen the runway a little bit backwards. Like, okay, let's widen our view. When the Industrial Revolution hit, just before the Industrial Revolution, there were, I don't know the numbers, say half as many people on this planet. And are we better off economically, industrially, technologically today than we were at the beginning? Are there more people on this planet? Probably by double, since pre-Industrial Revolution. Yes. No one could fathom. One person's personal income was an entire city's budget, back then. Right. So, yes, some people will lose. We don't have too many blacksmiths anymore. Thanks, Henry. Right. For that. But now we have. We lost a dozen blacksmiths on a Manhattan corner, and we replaced it with 100,000 factory workers, and it's just. Some people lose their jobs. Some people get jobs they never would have had before. but the industry grows, our economic trade grows. There's more products to build and sell, therefore more people. So, yeah, lights out, and it's the end of employment. Those are all contrarian views there. So for companies,
I'll give you a mic. Oh,
yeah,
sorry.
sure.
I'll give you two more examples here that I love. Lamplighter. That was a job. People, that was their job, was they
Sure.
lit the lamps at the end of the day and they went home to their family and they got paid a paycheck, and that was their job, was lamplighter. Elevator operator was a job.
Right.
So of course we must assume that walking down the street we see lamplighters and elevator operators out of work on the sidewalks. Well, of course we don't, right?
Yeah, right.
Those folks found other jobs and new jobs came to replace it. So this is the kind of, is in the short term, yeah, it can create some upheaval, it can create some uncertainty, it can create certainly unemployment and things like that. But new jobs are already starting to come out to fill those things. But again, like, when I talk to my clients, they can't find enough people. The last number I saw was that there was about a 500,000 person shortfall. This is from the Bureau of Labor Statistics, a 500,000 person shortfall in the manufacturing sector. People don't want these jobs in the United States. These are good paying jobs that are available right now. And my clients are like, we can't run a third shift because we can't find enough people to fill the factory to run a third shift. So they can't put out as much product. They'd love to, but they can't. So this is the problem they're seeing. It's not a question of putting people out of work.
Yeah, I think there's a stereotypical view of a factory, right? And it's someone running a machine covered in grease or soot, or sitting at a bench doing the same thing repetitively over and over and over and over and over. And yeah, those exist. But
yeah.
I think if we can take high school students, let them tour a gigafactory or a Amazon fulfillment center or any other like super with it modern factory, it would look so cool. It will drag people it'll be magnetic. It'll attract people into that because it's the ultimate video game. And
right.
You can be the nerd and work on a factory floor. We need more people like that on the factory floor, right? We need more me and you on the factory floor. And I think young people particularly can pick anything they want to do in terms of industry, because you and I are both technology immigrants. When you were born and when I was born, you were probably not born with a screen in front of you, right? You learned that sometime in your younger life. I was the same way. I had my company. I started my company 34 years ago, so I had it for 2 or 3 years before the internet even dropped on us, right? So we had to learn all this stuff. My grandkids were, the first thing they do when they're born is they slap their butt to get them to cry. They cut the umbilical cord and they hand them a laptop, or an iPhone or something. I mean, it's just the way it is. Right, exactly. I never taught my granddaughter or my grandson how to use it. I almost have to be careful because they try and hack my stuff all the time and break into my stuff. So, but the point is, younger people as technology natives versus immigrants have a huge advantage, particularly while we're in this transition of the silver tsunami, the old sages leaving, and young people that basically go, hold my beer, I got it from here. Right. I'm already on the floor. I already know more than the guy who's leaving. So they're so valuable right now, and I think that if they're into tech, they would find a factory job more fulfilling than what they view as a Silicon Valley tech job, right?
100%. Yeah. I mean, being able to see, I was always fascinated with how stuff is made, right? I used to watch that show, How It's Made on Science Channel. This is before I even started here, right? Like, I mean, now I've gotten to go into hundreds of factories and seen how things are made. And I'm still like a little kid when I get to go into these factories and see how stuff is made. I think you can carve out a great career. I will say this, though, to kind of build on your last point. I think the onus is gonna be on some of these manufacturing companies to change their own perception of that dirty factory. Like, they need to invest in that because they're going to be competing for that good talent. They're already seeing a shortfall of folks coming into this industry. So if you want to attract the best talent, you better just simple things, but you better be focused on culture. You better have a well-lit factory. It better be clean. You better be like focused on benefits and focused on, work-life balance. And I've worked with great clients that have done all that, and they're attracting good talent and they're keeping them for a long time. But like you said, there's still lots of factories out there that are kind of dark and dank and dirty and don't have good culture and have never really focused on that, and they're going to continue to have high turnover and I don't want to see that. But I'm just saying, like, that's my message to some of these manufacturers is, and they're already on this, but like to start to change that perception.
Yeah, they're going to go the way eventually of a canary in a coal mine, right? It'll be the way we used to do it versus the way we do it today. They'll be the comparison. Right. So for companies just beginning their digital transformation, where should they start? What should they start with? Technology? Should they start with culture? Should they start with data strategy? All of the above? None of the above?
Well, so I'll say it's funny you threw culture in that list. I'll say culture, yes, but that is upstream of us. You got to have the right culture. You got to have the right mindset before you even engage with a a system integrator like RoviSys. But the next step I would say is start with use cases. So I always say use cases should lead, technology should follow. And that is a very different message than what they're hearing from the vendors, the IT vendors, the AI vendors. They're saying, here's my product. And of course, they've got a hammer, and so everything's got to look like a nail. Mm-hmm. And so they're saying, here's my product, use my product. Let's go find things where my product can apply. And I'm saying, no. We need to find high value, high ROI use cases where AI can make a huge impact. We should be finding those use cases where it's, 6 digits or above. Those are the types of use cases that we want to find. High ROI use cases, annual return use cases. Those are the things that are going to move the needle. And then I always say, and I know it sounds self-serving, get an OT system integrator involved, even if it's not RoviSys, someone that has expertise around implementing AI on the plant floor. Don't just talk to the vendor, talk to a system integrator who can actually implement these projects, who can give you an independent voice in the room and cut through the hype. Right. So a lot of these AI vendors, they have a lot of motivation to build a lot of hype around these things and a lot of uncertainty around them. And so get an OT system integrator in there who can kind of cut through that and get right to here's what it can do. Here's what it can't do. Here's where we've seen it successful. Here's where we haven't. And be able to get to that very quickly. But yeah, use cases should lead, technology should follow, and then have that trusted partner there, that system integrator who you can help you along that path.
And you need to be there to let them know, don't throw out all your light bulbs yet. There's still going to be a lights-on factory, right? So what are some of the biggest misconceptions? We talk about what AI can do. What are some of the biggest misconceptions about AI in the manufacturing arena? I'm sure you hear those every day.
So I do. And so what's so funny is that it's the two extremes. So I either go into a customer and they underestimate the capability of AI. They go, well, it can't possibly bring value here. We've got such a unique, process or whatever. And so I immediately start giving them examples of customers doing things in their industry. And they're like, oh, it can do that? Like, yes. So they either way underestimate the capability, or what I'm seeing now since the launch of ChatGPT is I'm seeing people who overestimate the capability. And they think that it's Skynet. And they think that it's going to be able to come in and run the factory for them. And I'm like, no, it's not that either. Yeah. Right. So the answer is somewhere in the middle. Where AI really thrives is in very narrow use cases where it can really apply expertise. Right. So in manufacturing, one of the things that most people who you and I know, but people who are outside of the industry may not, is that there are many parts of the process where it's as much of an art as it is a science, where the expertise of the operator has a direct impact on what a material impact on what the final quality, on the final throughput, So when you have an expert level operator who's working that part of the process, they can make more product better, faster than if you have a novice operator working that, right? Now, but if you think about it, the machines do all the work, right? So why would it be that the quality, the expertise of the operator would have that much of an outsized impact? But it does. That's the thing that people don't realize. So taking AI and applying it in very narrow spaces where it can really shine, where it can make recommendations to an operator about here's what I would do next, here's what I would do next. And we have AI that can do that today. It's not science fiction. We have AI that can be that expert, process optimization expert that can actually make you a better operator as you're working that part of the process. That's where it thrives. Now, I will say one more thing though about generative AI. So generative AI, which is of course those are the LLMs, the chat GPTs of the world. It's also the image and video generation. That's all under this generative AI umbrella. Generative AI. Obviously, it's making a big impact across a lot of different industries. And of course, we're seeing it in manufacturing too. But my message to my clients is that we need to be very careful about implementing generative AI on the plant floor. It is a very new technology, and it has well-known limitations. And we cannot just shove ChatGPT down onto the plant floor. The plant floor is still a high-risk area. If you give the wrong information to the wrong person at the wrong time on the plant floor, you could kill somebody. There's a reason why no one would accept the idea of putting generative AI in surgery and the surgeon stopping what he's doing and going and asking ChatGPT what the next step is. And yet somehow we've got manufacturers who are thinking that that's the appropriate thing to do and to shove generative AI down on the plant floor. This is still a high-risk area. So I'm just saying, look, should we be looking at it? Yes, that's fine, but we really need to tap the brakes on this. This is typically a very risk-averse industry. They don't typically just throw stuff down on the plant floor because you can't disrupt operations, and yet they all are racing towards generative AI as the solution. And I'm trying to say there's other AI, proven AI, stuff that's been around for decades that we can do today. And keep an eye then on generative AI, and let's see where it goes and if they can fix some of these limitations, and then we can start to move that down onto the plant floor next.
Yeah, I hosted I'm the chair of a technical conference that happens every year in the electronics manufacturing space in Hawaii. I pulled a great straw on that one. But I recorded an episode of this show, Reliability Matters, live at the event, and it was an AI panel. It was an AI panel of pretty prestigious university professors and a couple of students, PhD candidate students. So it was not layman view, but not like certified AI experts, if there is such a thing, but kind of a practical view. And the professors were also electrical engineers. And as in preparation for it, I use ChatGPT daily, right? It helps me do a lot of research for the show and,
Sure.
things like that. But I asked it, I told it what I was doing. I said, create a bullet point list of things you don't do well. And to my surprise, Sam Altman hasn't quite written the code to, about, self-deprecating remarks coming from chat. But it gave me pages of stuff, and then I reduced it to like one-liners. But it was basically I hallucinate, I routinely get things wrong, and I will express overconfidence in an answer when I should say I'm presuming this to be true based on other factors, but it's not verifiable, and all sorts of stuff. If you just read that, you would never use, AI, and now I love it. I think we're watching history being made right in front of our eyes. Usually we don't realize it was historic until maybe the next generation. We're seeing it right in front of us. So I'm a huge proponent. But it's to your point, generative AI is kind of the Wild West, and I think it's probably right more than it's wrong. But if it's critical, I don't want my pilot, looking at an iPad, making every flight control decision based on what AI suggests. I'm not there, or my surgeon, or my dentist, or my lawyer. I want them to use it as training material, as helpful stuff, data analysis, wonderful, but not quite there yet for critical things. What are some of the most common mistakes? Maybe one of them is relying on generative AI, but one of the most common mistakes you see manufacturers make when they attempt a digital transformation?
Yeah, so it really comes down to expectations management and use case selection. So These projects, I say this all the time to customers, these projects typically don't fail because of technical problems. We can get over the technical problems. These projects fail because of internal politics. Either expectations haven't been managed by the digital transformation committee or to the people who are reporting to that committee, and so you typically have overblown expectations. You haven't done organizational change management, which is something we've understood now for decades. Like, that's not new. Like, if you implement new technology, you better be doing some form of organizational change management. This is no different. AI is no different from that. And then the other thing, like I said, is use case selection. So I've been in these meetings with clients who get super excited about a specific use case that they're really pumped about. And so, and maybe, so typically when we look at those use cases and we're figuring out which one to go after, there's two things that are at the top of the list. One, we talked about data. Do they have the data? Is it clean? Do we think that the quantity of data is going to be good enough for us to be able to build it? Let's say that that's true. But then, so they get all pumped because they've got the data, they got this really exciting use case. And then I ask them the question, what do you think roughly, back of the napkin math, what do you think roughly the ROI is for this project? And they go, well, I don't know, maybe like 50, 75K a year. I'm like, guys, that's not going to cut it. I know it would be really cool to do this project, but I can tell you, because I've been at this long enough, that the bean counters that are 5 steps above you, that's not going to cut it. That's not going to justify this project. And one of the things that is so different now than it was when I started my career. When I started my career, there were still clients that would say, well, we're looking for like a 3 to 4 year payback on this project or whatever. That's gone. Everyone is saying, I need at least a 12-month, if not faster, payback on this project. So, I'm telling these guys, like, we've got to look for those projects that are going to have, especially for the first AI project, you got to knock it out of the park. Like, it's got to be a home run. And so we've got to find something that's going to have big impact, immediate impact, and that's measurable in dollars that we can point to. Because then you can start to justify the second and third project based on that and build that snowball of success. But you got to start somewhere. And so, so use case selection and expectation management are typically the two things, which is not probably what you thought. You thought I'd say something about data. You thought I'd say, it's not. It's politics. It's internal politics 100%. And making sure that you're positioning these projects to be successful right from the beginning.
Well, I think, several years ago, several decades ago, industry switched from customer-centric, customer-focused decision-making to shareholder-focused decision-making. Mm-hmm. Boeing was an example of that, a tragic example of that. When they bought mm-hmm. McDonnell Douglas, they brought on the McDonnell Douglas make the shareholders happy philosophy. And I think a lot of their decisions, in my opinion anyway, so Boeing lawyers, go away. This is just opinion here. They started making very short-term economic decisions, and they lost their, in my opinion, their visionary, let's do something that will have no ROI for another 20 years. That's gone. And we can argue, economists can argue whether that's good for society or not. But to your point, a $75,000 ROI on a multi-million-dollar business is an accounting error, right? And so you'd mentioned earlier, I interpreted what you said as low-hanging fruit. So minimum six-figure stuff. Mm-hmm. You apply AI to that. Do you think an ROI in that, admittedly low-hanging fruit, start there? Do you think that can be 12 months or less? Is that?
Oh, it definitely can.
Definitely
100%.
Can. Okay.
Yeah, it definitely can. Now, that 12 months, that's assuming that the data, is there and that there's not huge gaps in the data. I mean, all of that's got to play out. And that's 12 man months. When you map it onto calendar months, and then IT takes 3 weeks to get us access to this system, and, like those types of things can push it out, in calendar months, maybe a little longer. But absolutely. I mean, the longest projects that we estimate right now are 12 months. So we're basically set up to execute these AI projects, and that's in the field delivered, running in deployment in 12 months. That's our plan, because again, I can't get sign off from a customer if I say it's 18 or 24 months before they're going to see this thing
shareholders won't be happy if they're investing money that's,
and again, right. You can wish that it's different and hope that it changes, but this is the reality we live in right now. So if I want to execute these projects, I gotta focus on that.
What technologies or trends, such as edge computing or digital twins, or predictive maintenance, do you believe will most influence reliability over the next 5 years, 10 years?
Yeah, I think that there's been an inordinate amount of focus on predictive maintenance, and I am actually not a big proponent of predictive maintenance. I think that predictive maintenance, as it's narrowly defined, as the ability to predict, within so many days, 24 days, 30 days, 60 days, or whatever, to be able to predict that this piece of equipment is going to fail, I think is kind of a unicorn. And I think we've been chasing a unicorn in this industry and I think I'm in the right place to say that. I've got the expertise. I think we've been chasing a unicorn around predictive maintenance for too long now. And I think that we're throwing a lot of money after that, chasing that unicorn, and I don't think it actually exists. I think now I've come to the conclusion in my career that we need to be instead focused on what I'll call smart condition-based maintenance. And condition-based maintenance is one of those things that's been around for 20 years, and I still have customers that aren't even doing condition-based maintenance. So we can leverage AI and we can build on top of condition-based maintenance and make those systems smarter, right? Am I going to be able to predict within 95% certainty that this rotating equipment is going to go down in the next 60 days? No. And I'm going to make a claim that no one's ever been able to do that. Right. And then especially, when you put me in a factory where you've got 15 different vendors in there, all with different rotating equipment, some of these vendors don't even exist anymore, and I'm supposed to be able to build a model that's going to be able to predict that these things are going to fail? No. Right. But we can absolutely be smarter about building preventative schedules, maintenance schedules. We can build those schedules smarter with condition-based maintenance, right? And that's been around for a long time. That's where we're looking at run hours. We're looking at amperage. Yes, we can take vibration into account, but we're looking at those factors, and we're trying then to be able to look at lifetime of that piece of equipment, look between, mean time to failure, look at trying to make smarter decisions about that based on runtime, instead of trying to build this all-knowing, all-seeing model that's going to somehow predict it. So predictive maintenance, I'm not bullish on in terms of its ability to make big changes there. I think that digital twin, I think, can have a very big impact. I think it needs to be done right. I think that digital twin is another marketing term that means something different to everyone, therefore it means nothing. So digital twin, I think that when you build it on real data, and I think that there does need to be some kind of a simulation component to it. I think that the combination of those two things is really powerful, and I think that it's somewhat untapped right now. I think that when people think about simulation, they think of first principles sims. And we do some of that here, like we do robotics here. So, we've got to build a first principle sim to determine whether or not that robot arm is going to hit something when it moves. Like you've got to do that level of first principle simulation. But there are other types of simulation, like discrete event simulators, that we can do that are a much higher level of simulation, simpler to implement, cheaper to implement, but can have big impact. And we can build some really cool stuff with AI on top of a discrete event simulator. So I think digital twin and simulation is probably, if I had to pick one thing, I think that's going to have the biggest impact moving forward, on maintenance, on reliability, on making sure that these assets stay running.
We're about out of time, so just one more question. What advice would you give manufacturing leaders who want to build if there is such a thing, a future-proof plant that balances reliability, adaptability, and innovation?
Yeah, and it's real easy. Get started. You need to get started. Like
you're pulling a Nike on me. Just do it. Right?
I'm telling you, lace up your shoes and get started. I have been in so many of these meetings where I won't mention them, but they're a steel customer, and I was in a meeting last year, and their CIO is there, and they're in half-day meeting. We're talking about AI, and we're putting all these plans up on the board, and we got all these great ideas, and they're excited, and I'm excited. And then a year later, I got called back to that same customer, and I'm in that same boardroom, and all the leadership has changed, and I'm doing the exact same thing over again. Now, if that first team had just started, right, a month or two after we had met and taken that first step, we wouldn't be having the exact same meeting a year later. Just get started. Doesn't mean you have to start right with AI. We talked about data, right? If you don't have a robust data infrastructure and data strategy right now, start there. That's a great place to start, right? And there's all kinds of vendors now in that space to do data on the plant floor. So get started there, but do something. Like it's time. The time for talking is over. It's time now to start taking some action and take those first steps on that digital transformation journey.
Excellent. Well, for my listeners or viewers who would like to get more information on RoviSys and this fascinating world of not quite lights out factory, we'll keep a nightlight on for you at least.
That's right.
The information on the RoviSys website, the URL will be there. If you're watching this on YouTube, just look down here where it says see more, and the information will be there. And if you're listening to this on your favorite podcast app, by all means, go to that podcast app, look at the show notes, and that information will be there. Bryan DeBois, RoviSys, thank you so much for being my guest today. I love this conversation. I love the whole subject of AI. I have the few push button, things that just kind of light me up, and one of them's aviation, and this is one of the other ones. So I again, at the risk of repeating myself, I believe all of us, whether we are embracing AI or scared of AI, we're definitely aware that this is a revolutionary moment. Almost everything in this industry is evolution. Pretty much everything we use today is just faster, smaller, cheaper, better versions of things we used in the past. And that can technically AI is that, but the application of AI is revolutionary. And it's just, to me, fascinating to watch. And considering that the acronym AI, less than 10 years ago, it was not artificial intelligence. By the way, one parting thought. I do think the industry would be better served if we kept the acronym, but changed its definition to acquired intelligence as opposed to artificial. I think artificial scares people. There's nothing artificial. It learns the way generative part might be artificial or presumptive, but the basic LLM model is we trained it. It simply is a really good student, and it has an unlimited library of stuff. So I think it's acquired intelligence. It acquires more intelligence than a human does at a much faster rate, but it acquires it much like we did. We read, we listen to lectures, we watch videos, and we learn, and then we make assumptions based on that. It's no different than humans. And people that think that AI can make a mistake, we shouldn't trust it. Well, a lot of doctors make mistakes. A lot of pilots make mistakes. That's right. It happens every day. It's tragic. And if we can make the odds less likely, more in our favor, I would run toward the light, not fear it. But anyway, that's just right. The world according to Mike. Bryan, thanks so much for being my guest today. I really appreciate it. It was a fascinating subject, and I wish you and RoviSys continued success doing what you're doing.
Thanks, Mike. Appreciate it.
Before I wrap up, here are some final thoughts. If there's one takeaway from this conversation, it's that the future of manufacturing isn't about chasing technology, it's about applying it with purpose. AI, data, and digital tools only deliver value when they're grounded in real-world problems, real people, and real processes. Bryan shared a practical, grounded view of what smart manufacturing actually looks like, starting with the right questions, building trust in the data, and using AI to support, not replace, the people on the plant floor. Digital transformation isn't a one-time project. It's a journey that requires leadership, patience, and a willingness to evolve. And as we heard today, the companies that get it right won't just be more efficient, they'll be more resilient, more competitive, and better prepared for what's next. If you're a manufacturing leader, engineer, or an entrepreneur wondering how to begin, or how to move from pilot projects to real results, this is a conversation worth revisiting. Now, that's a wrap on another episode of Reliability Matters. Thanks for hanging out. Whether you listened on your favorite podcast app or watched on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, consider giving us a thumbs up and subscribe. Those two simple clicks really help us expand our reach. And a big thanks to PCB Chat from the Printed Circuit Engineering Association at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@reliabilitymatterspodcast.com. Want to learn more about the podcast? Just head over there, reliabilitymatterspodcast.com. Again, thanks so much for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.